Hi, so our project is a California housing price prediction. We are so what our project does is we used a data set we found on Kaggle that holds 20,000 entries from the 1990 census about housing prices. It contains information like location, median house age, total rooms, and the median house value. Our goal is to find patterns among these features and predict California housing prices.
How our project works. We have 5 steps. The first step is data collection, and it collects data. We have EDA, and the third step is data processing. The fourth step is machine learning modeling, and the fifth step is model deployment.
Okay, here's exploration of data, and here's a heat map. And a heat map, it relates like the factors, and the lighter it is, the okay. So the darker it is, it shows when two different factors are being compared, and light when two same factors are being compared, and then that tells us the age. Okay, then the pie chart. The pie chart shows all of our data, and it shows us the percentage of each house and how close it is to the ocean and where the homes are located. The scatter plot shows us 20,000 houses in California, along California, and it shows that houses are older in San Jose and cities near there. A histogram. A histogram is a bar graph representation that shows 20,000 houses in California and what they're worth. And it goes from 65,000 to all the way to 500,000. Visualization of crucial features. The most crucial factor in our data set is the way you have to analyze housing value, and we compare these factors to see which variable affects the housing value.
So we used 5 different supervised learning model programs for our regression machine learning. The first one we used was linear regression, which is a model that finds the best fit linear line between the independent and dependent variables. We used root mean squared error to easily plot the difference between the estimated and actual values of a parameter of the model. And then the next one we used was support vector machine. It's not like the other regression models because it doesn't try to minimize the error between the real and predicted values. Instead, it predicts the best fit line within the threshold and the distance between the hyperplane and boundary line. And we used mean squared error for our machine learning. We also used K nearest neighbor, and that is a program that predicts the best value for K, and our K nearest neighbor was 11, which represents the ideal neighborhood to use in our code to decide which factors relate the most. We also used random forest, which combines an ensemble learning method with decision tree framework to create several randomly drawn decision trees from the data, averaging the results to get a strong prediction. And finally, we use lasso, which is a shrinkage selection method for linear regression models. Our goal for lasso was to obtain the subset of predictors that minimizes prediction error for a quantitative response variable. We used mean squared error for that too.
For our model, we picked K nearest neighbor because it had the lowest mean squared error, because it used the distance between data points to make prediction instead of trying to use the line of best fit, which was less useful because the large amount / variety of our data. So for our conclusion, we have developed a regression AI that is able to predict a house's value in California based on different factors. We've created graphs to analyze and understand our data, and we utilized supervised machine learning algorithms like King-Nearest Neighbor and reinforced to sort our data. So our research is significant because we've identified and analyzed the primary factors that raise a house's value and use that to make our model. And then so our product can, what's the use case for our product? Our product can give accurate house values to like real estate agents or homeowners/buyers. So like agents can use it to get a house value estimate to their clients, or like homeowners can or buyers can want to know the average price for a house with like certain amenities can use it too. Potential buyers could be like real estate companies who are looking to own it so that they can give it to their agents. And also users could be homeowners who are looking to use it so that they can know the right price for, so they're not getting ripped off.
Right here, we have a form which allows you to try our program. You'll enter your information on this, and then when the site reloads, it will tell you what the approximate value for your house is. And so all you really need to do is enter your information, information into this that fits the guidelines, and make sure that for numerical questions, it's exact or close to. And so as you'll see, we just ran through some information, and as a result, right below it, it says that the estimated predicted value of this house is approximately $121,236. So yeah, I'll hand it off.
Our team members are these students: Nathan, Cassidy, Jackson, Alex, Julian, myself, and our project mentor was Jonathan.